Welcome to homework.
Chapter 21, Question 20. Each of the following nuclei goes through either beta decay or positron emission. Predict the type of the emission. So tritium, we have an isotope of hydrogen, that is 1 and 3. So if the number of atoms are smaller than 16, what we have is neutron to proton ratio equals to 1. So if the number of neutrons are higher, then we need to lower this number of neutrons or increase the number of protons. So let's see what we can do and what happens if we do that. So let's say this is going to be a positron emission. So it's going to be 1 to 0. And then what we're going to have is something that, let's say that is an X, and this is going to be 0 to 3. Now, this, when we look at it, actually has a even higher neutron to proton ratio. Actually, it's 0 protons, so the ratio is going to be an infinite number. So we don't want that, obviously. What about if we do a beta decay? It's going to be -1 and 0, plus this time we'll have an atom that is 2 and 3. So this number is this time when we do number of neutrons is going to be over here a 1. 1 over 2 is going to give us 0.5. This is also not the best number that we can ever come up with, but it is way better than having 2 neutrons divided by 1 proton, 2, because this value is closer to 1, which is what we want, than this value. So if we'll go with a beta emission. So what else we have? We are going to have SR, that is 38 and 89. Now SR is going to be between, this number 38 is between 16 and 56. So in between, this neutron to proton ratio has to be 1.15. And if you look at what we have over here, 89 minus 38, we have 51 uh, neutrons. And if we divide 51 by 38, what we're going to get is a very much bigger number than 115. So this is going to be 1.34. 51 divided by 38. And this 1.34 is higher than this number, so which means we have excess amount of neutrons, and we need to convert the number of neutrons to the protons. And what does this for us is, again, over here, a beta emission. So for this, we're going to have a beta emission. So A, we had beta, and B, we had beta. C, what we have is iodine 120, and iodine is going to be 53. So for 53, again, we need 1.15. And let's look at how many neutrons we have. 120 minus 53. We have 67 um, neutrons, and 67 divided by 53 is going to give us 1.26. Again, this is a high number of neutrons. We need to decrease the number of neutrons. So this is going to be, again, a beta emission. And lastly, we have silver is going to be 47 protons and 102 total mass. And what we have is going to be 55. This is the number of neutrons. So if we divide 55 by 47, what we're going to get is 1.17. And 46 is again in between this 16 and 56 in the belt. And basically, this is very, very close to 1.15. So I don't think this will go through anything, but if it has to go through something, which I highly doubt it would, then we need to again decrease the number of neutrons. And again, that's going to be a beta emission.